Hello, in this video we're going to be talking about special cases in linear programming. First of all, let's start with unbounded LPs. As you can see in the graph, this is a maximization problem. So as you can see, the objective function can always increase without violating any of the constraints. So for the case of unbounded linear program, the objective value can arbitrarily get better without becoming infeasible. So here we say that we have no optimal solution and that our LP is unbounded. Okay, so what happens when we try to solve an unbounded LP using the simplex algorithm? We're going to be using a different example for demonstration. So we have this LP. We do the usual. We write our model in the standard form. We go through a few simplex tableaus. This is tab 0. So here the entering variable is x2 and the exiting variable is s1. Then x3 enters the basis and s2 leaves. As you can see, we still have positive numbers, so we haven't reached the optimal yet. We go as usual until we reach this tableau, tab 3. So as you can see here, S1 is the only value that has a positive C-bar value, so it's selected as the entering variable. But when it comes to calculating the ratio, we can see that the ratio test fails because all the elements in the pivot column are either 0 or a negative number. Hence, we can here say that this LP has an unbounded solution. So if you ever come across an LP where the ratio test fails, you can say that the LP is unbounded. The second special case we're going to talk about is an LP with alternate solutions or multiple optimal solutions. So as you can see here in this graph, using the corner points method, we found that point A and D have the same objective value of 6. So both of these points are actually optimal, which means that this whole segment is optimal. So we have an infinite number of the optimal solutions. If we were to use the slider method, we would find that the Z line would be parallel to C2. So here we say that we have multiple optimal solutions. If we were to use the simplex method to solve an LP with multiple optimal solutions, we would do the same thing we do every time. We write the LP in the standard form and start working on our tableaus as usual. As you can see, after the first iteration, we have reached optimality because we have no positive numbers in the C-bar row. But we have something peculiar. So we have in the basis, we have x2 and s2, but they're not the only two variables that have zeros in the C-bar row. We can find that x1, which is not in the basis, also has a 0 in the C-bar row. So hence we can conclude that this LP has multiple optimal solutions. So if x1 were to enter the basis, we may obtain another alternative optimal solution. We will have the same objective value, but x1 could be a part of another solution to this LP. So if you ever come across an LP that has a variable which is not in the basis with a 0 as its C-bar value, you can conclude that this LP has multiple optimal solutions. Another special case would be the infeasible linear program, where there is no solution that satisfies all the constraints, as you can see here in the graph. I will not talk about infeasible linear programs while doing the simplex algorithm because you haven't talked about it in the lectures, but I guess it's enough to be able to recognize an unfeasible LP in the graphical representation of the LP. If you have any other questions, any questions about the simplex algorithm or the graphical solution, please let me know as soon as possible, and thank you very much for listening.